with our session on C programming language, and we will continue to learn more about the dynamic memory allocation, malloc and free. And after that, there is another topic today which we will try to discuss about is something advanced topics about how function works in C programming language and how can we utilize them. So if we revise what we learned yesterday, so for example, let me create a new C file vim.c, and then inside here we will create, first our purpose is to create a linked list. So rather than creating a yes, we can create a linked list and mark it as struct, and inside that linked list we will mark that linked list, and we will have two items. The first will be int, which will be the item, and the second will be the pointer to the next. And the pointer to the next means that it will be the pointer to a structure linked list, and we will name it as next. So is this fine? Type def. Now it is fine. Still there is one error, expected semicolon before struct. So we have given, okay, sorry, my mistake. And here we will name it as linked list. Okay. Then we will create our main function, and inside our main function, what we have to do, we have to simply create a linked list. For example, we want to create a simple linked list, and for that, for example, linked list 1 equal to, we will create a create function, and inside the create function we will simply pass a item, and that would be an integer. So first is 1. Now in order to create a function, we will create a function that will return a linked list. So we have to mention here linked list, sorry, yes, linked list as the return type, and then the name of the function create, and it will take an integer and which will be value. Okay. And this seems to be fine. Okay. Anything else required? No. And inside that linked list we will create simply a linked list L1, which will be equal to a structure, and the structure will first contain the value of an item, and that is passed as value, and the second item will be the pointer to the next, and that we can consider right now as null. And then we are going to pass that to nothing, and we can directly return our L1. So that is fine. And what is problem here? First using this function, then we can create L2 using create function 2. The value of 2 will be, sorry, 2 will be linked list. Then we can point, for example, L1 dot next equal to L2. But the point here is, if we are going to use L1 dot pointer equal to, will point to L2. What is that? Oh, my mistake. Linked list L1 set but not used. We have used L1 here. L1 dot next is equal to address of L2. L1 set but not used. And then what we can do here, we can create a display function. Won't do anything. Display, and it will take a linked list, which is a head. But if we pass the linked list, it will not work. We have to pass the pointer to a linked list. Yes, pointer to a linked list. And here what we can do here, while head is not equal to null, what we can do here is we can print f, then we can pass the %d backslash n, and whatever will be our head, whatever will be its item. That is fine. Yes, that is fine. But we have to close it, and then we can do head equal to head next printf. And in order to use printf, we have to include hash include std io.h. L1 set but not used. Then we can use display function, and in display function we are going to pass our head and not head, we are going to pass address of it. Then it will work. So gcc dash cemp.c, sorry, gcc.e. If we run it, it will print 1 2. So as you can see, it is working fine. But sometimes the problem arises when we are not sure of how much memory we need. So for example, here we already knew that we are going to create a linked list and returning the linked list, and then we are passing the pointer to it, and it is working absolutely fine. So for example, what was the here they created and returned a pointer to it, but rather than creating a pointer to it, what we did is we directly return the element. We didn't return the address, we directly return the element, and we store that element in a specific variable. So that was also correct. The another way what we could have done of, as we have seen yesterday, is we are creating a we are returning a pointer rather than returning a specific data structure directly. For example, island, if we want to return a pointer to an island, so then we can use malloc, and now we can try that. So this was one solution of creating, and the other way of creating is linked list. We can which will return a pointer to a linked list, create p, and it will also take the value. The difference would be here now. We will create a linked list pointer L1 equal to, so we will call a malloc function, and will malloc we will tell what is the size of linked list, the structure is the size of it. It will create a dynamic memory in the heap. Now what we can do is we can directly access the value L1 uh, item equal to value, and L1 whatever will be the next element equal to null. Okay, null. And what we are doing here is now we will return L1. Same thing. Here we are returning directly the structure, and here we are returning the address of the structure. But in order to return the address of the structure, we can't use the uh, we have to use the dynamic memory. We cannot use a stack, because if we are going to use a stack, then as soon as the function closes, as soon as the function ends, the memory of the stack gets freed, and whatever address we are returning, there will be nothing at that point. Okay, so if we are using this function, let's assume we are using let's change it a little bit. Okay, and what we are doing here, we are returning its address. Fine. and rather than creating, we are creating a pointer. We are creating a pointer here, and now what we are doing, okay, and here hmm, equal to L1, next equal to L2. Yes, absolutely fine. So what here will happen? Here first it will create a linked list and return the address of the linked list. But this linked list is getting created in the stack, and as soon as the function ends, it returns the address. But as soon as the function ends, the address will point to nothing because the stack has been cleared up. So if we are going to compile it, return L1. Warning, function returns address of local variable and the compiler does not allow us to do this. Compiler shows us that this is a foolish behavior. It will not work because it is returning address of local variable and it is not, I don't think it is safe or is some sort of correct behavior to do. So you can see. But what if, no? But what if we are going to, rather than doing this, we are creating a specific structure. We are creating a specific structure in stack and we are returning the whole structure. So let's assume we are, let's try to print f percent p comma address of L1. Okay, so that is fine. So when we create it here, let me take, let me select it, then address here and display, and now it is fine. So now I will print address of L1 first and then address of L2 first. So first it will print the address from the function, then it will print the address, what the value is when the value is being returned. Compile, then we will execute it. My mistake. Backward. Okay, let me compile it again. Run it. So you can see here when it was in the function, the address was different. When it is in the main, the address is different. And when it is in the function again, the address is same. And when then it comes back to the main function and the address is different. So when the object is getting created here, it is using the same stack memory and the variable which is being created in the stack memory is different. This time the variable has value as 1 and the next time this memory is being used, the variable has value 2 and it is getting returned and then the new memory is being used and we are using this memory. Okay, but let's assume now we want to create the data inside heap. Okay, so what will we do is linked list, which is a pointer L3 equal to, now we use create p, we will pass a value 3. So now L3 next equal to address of, once again what I am doing, L1 next equal to L2. So what I will do is, sorry, L2 dot next equal to L3. Okay, this is also fine. Then I will do linked list pointer to L4 equal to create p and L3 next arrow because it returns a pointer L4. Now if I compile the program, it will print 1 2 3 4. That is absolutely fine, it is working. But the only difference here is we created a memory inside the heap. This is a heap memory which we are creating when creating a pointer. So whenever we are using a heap memory, our responsibility increases. We have to use free. So I think this is a better way, not 100% sure, but this is a better way because it is not using heap memory at all. I don't know when we are returning the structure. So where this memory gets created, is it on heap? Maybe. So this is C1825705 C18. 05C28. We can check it over the internet. Struct is returned in which when a function returns an struct, it keeps at stack or at heap. So this is the question. Function returning a structure can be implemented by the compiler as taking an extra hidden argument, a pointer to the receiving struct in the caller's scope, possibly a temporary one if both the results is not stored. The function copies its local value to the destination one. In your case, both are stored in automatic storage. What is saying? The calling function allocated space on the stack for the return struct by the callee. The callee function allocated space on its stack for the return struct by the callee. Basically, since in your example main knows it's going to receive a struct animal, it automatically creates space on stack for it and passes a pointer. This is hidden from you. What happens at the assembly level to this newly created stack space to your animal new function? So he is doing the same thing, animal A, animal new, animal AUX, and it is returning an animal. So it is doing the same thing which we were trying to perform. The function has its own copy. So they are saying that it automatically creates a memory in the stack. It creates a memory in the stack. The function has its copy of the struct in the stack space. When returning, it copies its value to the caller stack space through the pointer it received. So it is saying that animal heap allocated animal, it creates an animal and then it copies that to classical implementation, which would represent most implementation of knowing better than assuming. So when in doubt, read the document. Okay, think something. Are returned by value in fact the only way? 1 second, I'm getting a call. 1 second. So this is the point we are using. Struct are defined by returned by value. In fact, the only way for anything to get onto heap is to for you to create malloc, calloc, or elloc, which we are not doing. So as per my understanding, you can dig deep into it, but this is better way to rather than using this. Okay, so now let's move ahead. All right. Free the memory, we are done. Okay, that is fine. So now the next thing is, where is it? Sorry, slowly, slowly. Now they are trying to discuss about some of the data structures. So here we are saying this is a map. Key is connected to a value, so it is a map. It is a doubly linked list. Right now, what we see was a singly linked list. The first element was pointing to second, but here the element pointed to the next element and also to its previous element. Linked list, which we saw binary tree, it represents a tree-like data structure. Top secret. Uh, What expects is the source code of a suspicious person identification expert system. This software can be used to record and identify person of interest. You are not required to read this code in detail now, but please keep a copy in your record so that you may refer it to during the ongoing investigation. Okay, so we can see here's the structure node, and it consists of a pointer to a question means string, uh, structure node no. Okay, yes, so it is pointing to a two nodes. One is no node and second is yes node. Okay, which is itself a node which may contain a question. So int yes no. Acha. So there is a function which takes the question and then answer is in of three characters. Printf percent s question mark y forward slash n colon question. F gets will read from the stdin answer 3 stdin. Okay, return answer 0 equal to y. If it is y, it will return true. Um, if it is not, if it is no or something else, it will return false. Okay. Then node create pointer to question returning a pointer. Malloc size of no and question yes and no null and yes null. Okay. So if and release, if n, then n pointer no, it is releasing that, and yes, it is releasing that, and question, it is releasing that, and then it is releasing. Correct. Now the main arises. Start node. Create does suspect have a mustache? Start node dash no equal to create Loretta Barnsworth and start node yes create we need a spoon. Okay, okay. Starts no will point to Loretta Barnsworth and start yes will point to this. Okay, so very so we are creating a start node. That is correct. I suspect have a mustache. But the start nodes no points to acha acha acha. Okay, so it is sort of creating a graph. Okay, got. If the answer is no, then go to this question. If answer is yes, then go to this question. Good. So node is current points to node. Okay. So current equal to start node while one infinite loop. If yes no, yes no was the question yes. Okay, and we are passing it the current question. So we are passing its current question. And but the current question current has no question. If current yes, current equal to current yes, else print suspect identified. So it will not go here. Okay. Else if current no. Okay. Else print f who's the suspect? F gets suspect. Node yes no. Yes no. Very confusing. Okay. So it is creating a tree. Okay. Has a mustache. Winnie the Spoon. Loretta Barnsworth. This is fine. What I understood. The program records the data using a binary tree. A binary tree allows each piece of data to connect to two other pieces of data. That is absolutely correct. So it is connecting to yes or is it is connecting to no. This is what the data looks like when the program starts. The first item or node in the tree stores a question. Does the suspect have a mustache? That's linked to two other nodes. If one of the answer is yes or another, and another if the one of the answer is no. The yes and the two nodes store the name of the suspect. The program will use the tree to ask the user series of questions. So has a mustache, one gold tooth, then it will reach somewhere else. So if yes, then this. If no, then this. If yes, then this. If no, then this. Okay. And I think that's what they are trying to do here. Nothing interesting. Now, software forensics using Valgrind. It taken achingly long time to track down bugs in large complex programs like Spy. So C hackers have written tools that can help you on your way. One tool on the Linux operating system is called Valgrind. Can we check? Do we have Valgrind here? No, we don't have. Can install it. A Valgrind can monitor the pieces of data that are allocated space on heap. It works by creating its own fake version of malloc. This revision of Snap was published using classic confinement and this may perform arbitrary system change outside the security sandbox. Uh, apt install. So when your program wants to allocate some heap memory, Valgrind will intercept your calls to malloc and free and run its own version of those functions. The Valgrind version of malloc will take note of which piece of code is calling it and which piece of memory it allocated. When your program ends, Valgrind will report back on any data that was left on the heap and tell you where in the code that was created. So we can verify this actually how it works. So so in the previous code which we wrote, if I show you this emp.c, we are not freeing the memory. So we are creating a memory linked list here and we are returning that memory, but we are not freeing it. We didn't call free anywhere. So there are chances of memory leak in this program. You don't need to do anything to your code before you run it through Valgrind. You don't even need to recompile it. But to really get the most out of Valgrind, you need to make sure your executable contains debug information. And for that, we can use gcc-g spice.c and -o. Debug information is extra data that gets packed into your executable when it's compiled. Things like number in the source, line number in the source file. If the debug information is present to Valgrind, we'll be able to detect the leak, which can be done by using gswitch. So how can we do that? Okay. Okay. So first, what we can do here is we can compile our program gcc-g emp.c-o emp. Okay. So guys, can you give me a minute? I will be back in 2 minutes just. Sorry for the delay. So we have used the G flag to add debug information. And now as we have installed the Valgrind, we can use this command valgrind dash dash d check equal to full and we can execute our binary. So I think it has detected something, one error from one context. And if we run the same command for gcc-g ll.c dash ol, and we can run the valgrind l. Um, last last zero errors from zero context, and here one error from one context. So it is detecting some sort of memory leak here because we are not freeing our memory here. So now how can we identify where is the memory leak actually? You will start Valgrind on the command line with leak check equal to full option, then pass it the program you want to run. That's what we did. Then it is saying that in use at exit 19 bytes in one blocks. So let's go here. In use, in use at exit 32 bytes in two blocks. 0 bytes in 0 blocks, and here it is showing 32 bytes in two blocks. So we are using some sort of memory. Total heap usage 3 allocation, 1 freeze, 1056 bytes allocated. 16 direct, 16 indirect bytes in one blocks are definitely lost in loss record of 2 out of 2. So it is showing us that our problem lies in create p function emp.c line number 33. Go to line number 31, 32, 33. So here we are creating this, but we are not freeing it. And in main, we are using 54 here. We are creating this memory and we are not freeing it. Definitely lost 16 bytes in one block, 16 bytes in one block. And if we look here, all heap blocks were freed. No leaks are possible, but here it is trying to tell us that you are creating this memory, but you are not freeing this memory. So how can we fix it? By creating a function free that will take the pointer to linked list. Linked list pointer L, and we will call free. We will destroy, and we will call free, and then we will use L. Okay. So rather than freeing up the whole memory, let's do one thing: only free the single linked list. We are creating two linked lists using the heap memory. So we will call destroy and then only pass L3. Then see what will happen. Once again gcc-gemp, and we will use valgrind emp. Let's see. So now it has, rather than losing the 30 bytes, it is now showing the 16 bytes in one block. And it is showing that EMPC 33, but at this point EMPC 58. So we are not freeing this memory. So now we will destroy this one also. Destroy L4. Now again compile it and run it. All heap blocks were freed, no memory leaks are possible. Amazing. So this is what we did also. And they are just asking it from their code perspective, and we just examine it from our own code's perspective. Valgrind said the leaked memory was created on line 46, but the leak was fixed completely different line. The Loretta data was put onto the heap on line 46, but the leak happened when the variable pointing to current test question was reassigned without freeing it. Leaks don't happen when data is created; they happen when the program loses all references to data. So here our program was losing the reference to data. In their code also. I don't think we can copy this code. Otherwise, we could have tried it. Okay, we can go ahead as we are able to understand how can we use Valgrind to solve our problems. So you can use it on your own cases also. You can create some program and try to detect that whether there is some leak in your program or not. So let's move further now. So now we are going to moving ahead to chapter 7, and I already mentioned we are going to discuss some of the advanced feature of functions. Basic functions are good, but sometimes you need more. So far you have focused on the basics, but what happens if you need more power and flexibility you want to achieve? In chapter you will see how to up your code's IQ by passing function as a parameter. So in some programming languages, you may have worked with some programming languages like JavaScript. You can pass function directly as a parameter to another function. But in C, this is also possible, but in a very different way. You will find out how to get things sorted with comparator functions. So we'll also have a look at comparator function. What if you want to compare two data structures? And you finally discover how to make your code super stretchy with variadic functions. Okay, amazing. So so as we can see, pointer to a character, array of pointer to character. So it is creating a array of strings, simple, and num at 7, fine. So it is creating a find function. Complete the find function so that you can track out all the sports fans in the list who don't also share a passion for Bieber. Beware, you might not need all the fragments to complete the function. Okay, so what it is, William. Matt likes these thing, and these thing. I want someone in the sport, but definitely not into Bieber. Just working out on art, movies and theater, books and dining, sports and Bieber. Mike, sport. Okay. So it is saying that how can we solve this problem? So it is saying that number of ads. So there was 7. String ADSI, ADI, ADSI, sports, STR. What does STR do? I'm not sure. I have to check it out on man page. STR function finds the first occurrence of the substring needle in the haystack. If it is haystack, it is needle. Got it. So first is the whole string and then what you want to detect. Fine. STR string sports and not STR ADSI common. Bieber must not be there. Printf ADSI amazing. You will be able to find it. So find William Josh. Fine. And sure enough, the find function loops through the array and finds the matching string. Now you have the basic code. It would be easy to create clone of the function that could perform different kind of searches. Hey, wait, clone the function. That's each version would only vary by like one line. Okay. So it is saying that, for example, there could be different combinations. For example, post or sports or Bieber. That could be the different as per the requirement. If you are cloning the function, you will have a lot of duplicate code. C programs often have to perform tasks that are almost identical except for small detail. At the moment, the find function runs through each element of the array and applies a simple test to each string to look for matches, but the test it makes is hardwired. So the trouble is that wouldn't allow find to check for three strings like art, theater, or dining. So it was saying that, for example, if we are going to use, so currently we are using only two parameters, sports and Bieber. It is saying what if, for example, we have to check for three strings like arts, theater, and dining. What will we do then? What you need is some way of passing the code for the test to find the function. So the passing the code for the test to the find function. So if you have some way of wrapping up a piece of code and handling that code to that the function, it would be passing the find function, a testing machine that it could apply to each piece of data. Yeah, exactly. So we can pass it art, theater, or dining, and it can apply that logic to each one of them. So how we can do it? So imagine you take our original search condition and rewrite it as a function. Return str as common sports, and so we are only writing a condition here, only a specific condition. And then in the find we are passing the condition, and we can call the function name match here. We can call the match function here and pass the argument, the current string, and then it will automatically perform operation based on that. Interesting. So Find sports no beeper, sports no or workout, NS theater, arts, theater or dining. So, but how can we do it? Every function name is a pointer to the function. Similarly, like an array, the name of the array is a pointer to that first element of that array. Similarly, every function name is a pointer to the function. You probably guessed that pointers would come into somewhere this function. Think about what is the name of the function really is. It is a way of referring to the piece of code, and that's just, that's just what a pointer is, a way of referring to something in memory. That's why in C, the function names are also pointer variables. When you create a function called go to warp speed int speed, you are also creating a pointer variable go to warp speed that contains the address of this function. So if you give find a parameter that has function pointer type, you should also be used to able to use that parameter to call the function it points to. So clutch engage, clutch disengage, and we have to go to warp speed 4 constant. So this constant gets created here in the constant memory, the name of the function. You will need to work with function pointers. So but there is no function data type. Yeah, that's true. So but this won't declare a function pointer. Usually it is present pretty easy to declare pointers and see if you have a data type like int exactly. You also need to add an asterisk to the end of the data type name, and you have to declare a pointer with int star. Unfortunately, C does not have a function data type. So you can't declare a function pointer like anything like function pointer. Why doesn't C have a function data type? C doesn't have a function data type because there is just not one type of function. When you create a function, you can vary a lot of things such as the return type or the list of parameters. That combination of things is what defines the type of the function. So here it could be speed, here it could be multiple values. So we don't know what is the type of the function. You will so for function pointers, we will slightly need to use slightly more complex notation. And what would that be? How to create a function pointer. So you want to create a pointer variable that can store the address of each of the function on the previous page. So what we have to do is int wrap function int. Okay. So what does it mean? Go to warp speed. And what is the warp speed? So go to warp speed. Let's check it again. It takes speed as a parameter and int as a return type. Int as a parameter, int as a return type, pointer to function. Wrap function equal to go to warp. And then we can pass that parameter just like calling to warp speed 4. Okay, amazing. So let's try it out quickly. So we will go back to and sorry, vim f.c. So we will go to here and create our main function, and inside main we will call a function, for example double. Okay, and int x equal to double 4, right? And we can print f percent repassation comma x, right? Yes, and here we can create a function int double that can take an int x. What it do will, it will int y equal to x into x, double. So we can do 2 into x and we can return y. Oh, my name of the function is fine percentage x and f. Okay, sorry. std hash include std io.h. Can compile this program and run it. Yeah, this is dot c and dash o f, and then we can run it. It is working absolutely fine. Now what we can do here is we can create a variable. For example, it is taking an integer. It is a pointer to double f double f, and it returns a integer. Okay, the correct notation. So this is also blocked and this is also blocked. And we have created a p underscore double f equal to, now we can assign double f to it, and when we have to call p double f, we can call double f, and then we can pass it the parameter. We can pass it whatever we want to pass it, and int y equal to, and here we can pass the value of y. Now we can compile it and run it. So you can see 8 then 16, and rather than passing, you can pass x. So the syntax is first the return type, then the number of arguments. So if we are going to, let's assume we are using two parameters, int x, int y, and here rather than y we are using z, we are returning z, and what we are doing here, multiplying x by y. So comma 4, and then here we are passing x comma x, and here rather than passing single int we have to pass two ints. And now if we compile our code, the first value will be 4 into 4, 16, and second will be 16 into 16, 256. Basic. So return type, then the number of parameters. Number of parameters means all the parameters it is passing. We are passing to that specific function, and pointer and a variable name. Okay, so clear enough? It is. Yes. So now we can go back to our code and we can write a little bit code for that. So what was the our code is, we are creating a ARR length which was approximately 4, and then we were creating character pointer to our array, ARR, yes, we can use array, which will be a array of elements. So there could be name. Let's assume I don't remember what they were doing. So there could be name. So a name or sports name or players, cricket players, Virat, Rohit, comma, and let's assume Rami, and then we can write the name of other team players, like, and then write the name other first, and so, and rather than using 4 we can use 3, and here we can create a array of elements. Okay, and then depending upon the find function, void find, so what will our function do here? It will return a boolean, and this will be our function two names. Let's assume our function has two names. It will take two parameter, a character pointer name 1, and the second is character pointer name 2, correct? And next bool is one name, which will take character pointer name. Fine. So I don't remember whether it is bool or boolean. Boolean. How do we define boolean? I don't remember honestly. Boolean. Bool. Bool was correct. What was the problem here? Unknown type name bool hash include std bool dot h hash include std dot h. What we can do, we can return int also, int 0 or 1. So this is fine. Character name, and the last thing it will take is uh, it will also take character the value of the actual string pointed to value. Okay, so it is fine. Now what we are going to do here is we are going to return str. So first is haystack value, comma, and then it is name without a cast. Acha, what is the return type of str? We have to check. It returns a character pointer. Let's save. See, save. But what it returns? String. This finds the first occurrence of the substring needle in the haystack. The terminating null bytes are not compared. These functions return a pointer to the beginning of the located substring. Okay, or null if the it will return a null. So what we can do, if sorry if equal to null, then 0. 1. That's fine. Incompatible implicit declaration. Why? Hash string dot h. Now it works fine. And for second, if str value value comma name 1 is equal to null. So or str value name 2 is equal to null. So either this is null or this is null. Any one of them is null, means any one string is not matching, then we will return 0. If both of them are matching, then we will return 1. Fine. And then we can create a find function. And what will our find function returns? It will return a character pointer. No, I don't think it will return a character pointer. It will also return, I don't know what it returns. So let's create it void till now. Find, find, and it will take a, and what we are going to pass here is our array. Uh, so array means character pointer arr comma, and the second thing which we are going to pass it to it is our function. but it could be one name or it could be two names. So what it does is sports workout, sports snow beaver. Okay, it is saying that we can't use it like this. It will be difficult because the type of the list of parameters is different. So what it is trying to say, the name Rohit, and name should be uh, okay, and name one character pointer name one equal to and character pointer name two equal to Sachin. Name one redeclared as different kind of symbol. Fonts. Name one is oh sorry my mistake value value. You have to pass it as string and it will automatically check. And the second thing we have to pass here, it is a function, okay, and that is pointed to fn underscore name, and that's argument. The argument it is taking a character pointer to value. And inside find, what you have to do here is array, and also sorry, you have to pass int which is length. Okay? So you can go for int I equal to 0, semicolon I less than length, semicolon I plus plus. Then what we have to do here is we have a name of the function. What we can do, if fn underscore name, we are going to call it with what? With the array and the index. Yes, if it is vector before token. Oh, sorry. So if this function equal to 1, but okay, if it is found, then we can do can print the list print puts can put arri else we can print puts not found. So now we can create our find function. At inside find, first we'll pass the length arr boolean. Second we'll pass our array which is arr, and the third we will pass our function, and our function will be, but the point here is we are calling the function name. So we are passing the name function for one underscore name. Okay, so we are only passing one name and Rohit, and then this should get executed and this should get printed. So gcc dash f and when 1656 Virat Rohit Shami not found because it executed for each of one of them, and If it's found, it's going to return as soon as possible. Okay. Now, if we are going to pass the two names, then it will execute and pass Thappa. But what if we are going to update the name here? So let's assume our name is not name is it, then it will not execute. So not found it. It is uh P, P. We don't need else here. Yeah, now it is right. Now if we compile it and execute it, not found. And we two names and when it doesn't work, and then we search in and then we compile it, this will work. Okay, so this is the exact thing which we were trying to accomplish, and we have accomplished in an absolute correct manner. So we have the function we use is str, and find inside find we were passing our function. So inside we exactly in the same manner the name of the function and the point it was passing. So but we were using value also, so I think this value is not required. Even if we are not going to pass this value, this will work. Yeah, okay, fine, absolutely fine. So the hunter's guide to functional pointers: return type, parameter types, and then the pointer variable, and then the pointer. Amazing. Return type, pointer variable with the pointer, and then the parameter types. And we are going to use, where is my highlight option? What happened? Ah, no, it is back. So this is very, very important. Can I undo it? Yes, I can undo it. So now I'm going to highlight it. Yes, yes. Change the color. That this is very, very important. Yes. Mm. So how could I sort functions or any type of data at all? Now I think this we will discuss tomorrow. So where we are at the sort function. Sort. So okay, so we will be able to complete it tomorrow, and also tomorrow we will continue with the something like swappable code. I'm not sure of that. Then 9, 10, 11, 12. Okay, so we will be able to complete this within couple of weeks. So thank you for bearing with me. Thanks a lot.